2, displacement. Okay, hi guys. So lesson 1, we talked about motion, but we didn't talk about what direction we were going. So in this first paragraph here, I kind of just gave an example of that. But what I'm really talking about there is that if I left from this point and walked this way at 5 kilometers an hour, and then walked back at 5 kilometers an hour, that makes a difference, right? Like, and you know from everyday life that we need to talk about direction to make sense of things. Because in one situation, if I walked, to the right and ended up here, and then walked again over there, I have two completely different situations. One where I ended up here, and one where I ended up back where I started. So we need to include direction, and that's where the word displacement comes from. We'll see that that's just a distance with a direction. But we'll go on to that. So two basic physics terms: scalar quantity and vector quantity. So a scalar just means that we don't care about the direction. It just means magnitude is another word for it. So just how big the number is kind of an easy way to think about it. Examples of scalars might be, speed is one. If I said I was going 10 meters per second, but I didn't tell you which direction I was going, I'm talking about a scalar quantity. Speed falls under that. Vector quantity, that just means that it has a direction as well. Instead of calling it speed, we now call it velocity. Same type of thing, but velocity just means it also has a direction. And this doesn't just isn't just restricted to speed and velocity. This is also distance. Like, distance is a scalar quantity. If I said I went 10 meters to the right, or 10 meters, but I didn't tell you which way I was going, that'd be a scalar quantity. That'd be distance. If I said I went 10 meters west, or 10 meters up, or 10 meters down, some kind of direction, then I'm talking about a vector, and I'm talking about displacement. So we just got to kind of get those straight in our head. Just for something to think about, what would mass be? Would that be a scalar, or would that be a vector? If I said something has a certain mass, let's say 5 kilograms. Well, it's got to be scalar, right? Because it wouldn't make any sense at all to say that something weighs 5 kilograms to the right, or 5 kilograms up. It doesn't make any sense. So things like mass would be a scalar quantity. Okay, so just a few little physics things I want to go over, just the way we write out the mathematics. If we're talking about a vector quantity, let's say velocity, then what we do is we put a little arrow over top of the V. V is the symbol for speed and velocity. They're both with a V. But if we were talking about velocity, so vector, we put a little arrow over top. That just means we care about the direction. If we're talking about a scalar, then we just leave a little arrow off the top of it. Okay, another couple of things. It's going to be that we are going to start talking about direction, like whether something's moving to the right, the left, up, or down. It's a lot better for math to talk about those things as being positive or negative. So if I said something had negative 20 meters per second, and you might look at that and be like, negative? How do you have negative speed? All the negative speed is going to, or negative is going to mean in physics, that's just going to mean maybe that our thing is moving to the left. That's all we mean by the negative. It's just going to the left. Or it's going down. And there's a few, I'll draw you a little picture here. This is kind of helpful to draw out, and I would recommend drawing this on your sheet too. We usually call up positive. We call down negative. We call left negative. And we call right positive. So kind of like you would think. This to me made obvious sense. This is what I would call positive. I would call up positive. I would call right positive. So that's what we do for positive for up and down, right and left. And then another one, which I think also is pretty intuitive, how you would want to label it. We call north positive. We call south negative. We call east negative. And we call, positive. I was testing you. Positive. And we call west negative. So the same thing, right? So get these kind of straight in your mind for sure, whether we're calling something positive or negative. Okay, distance and displacement. So distance is a scalar. It means that I don't care. So about the direction, I mean. So if I said something went 20 meters, but I didn't tell you anything about which direction, we're talking about the distance. Um, so remember, we're talking about the distance from some reference point. So we give that the symbol for distance. We were using this in lesson one. Um, Little triangle and then D. And this symbol is called delta in Greek. Okay, anyway. It means change in for all we care right now. Okay, so now displacement though. Displacement is different. Displacement is a net change in position from the starting reference point. And I'll show you what I mean. I'm going to turn the camera around so you can kind of see me and what I'm doing here. Okay, so let's talk about distance again for a minute. So distance, remember, was just how far you went in total. So you can think about distance. Let's say I started here, and then I walked this way for, I don't know, let's make it up and say like 10 meters. I walked 10 meters this way, and then I walked 15 meters this way. Well, you'd say the distance that I went, remember distance is a scalar, the distance that I went would be 10 plus 15. So I went 25, right? 25 meters, we're saying. But let's say, if we're talking about displacement, it's from the reference point. So if this is our reference point, then I went 10 this way. So let's say I went 10 meters. And then I went 15 back. So 15 this way. My displacement here is going to be what's from the reference point. So it's from where I started. So my displacement is going to be this distance from there to there. So I would say, if we're talking like, left and right being our vector quantity, or what we're talking about here, I'd say that I went, well, this would be 5 meters. So my displacement is 5 meters. So you get a different answer for distance and displacement. So displacement 5 meters, but it's not a vector yet because I haven't said which direction. So my answer here would be 5 meters left. That would be good. Like left is, that works for displacement to say left. It would also make sense to say negative 5 meters. In physics, we use the negative. If you put negative 5 meters, people that were looking at your work would understand what that meant. If you put it in the right context, it could also mean 5 meters down. It could also mean 5 meters west. It could mean like anything. It has to be within context of what you're doing. Okay, hopefully that makes sense. All right, so moving on down here. So a couple of examples. This one says a person walks 10 meters east, then 20 meters west, and finally 10 meters east. What is the person's distance and displacement at each point on the trip? So just like I was showing before, this is the person where we started, right? Went 10 meters east, so positive. You can think about, I guess if we're talking about distance, we don't really care about positives or negatives. So anyway, went 10 meters to the right, and then went 20 meters west, and then 10 meters east. So if you're looking at distance, part 1 right here went 10 meters. Part 2, it would just be 10 meters plus 20 meters, just the total distance. So it's just going to be 10 plus that 20. So now you're at 30 at point 2. And then at point 3, just went another 10. So now we're at 40. Displacement, though, we have to take direction into account. So right off the bat, we'd say at point 1, he went or she went 10 meters east. But it does matter, though, that you say east. It could be east. It could also be positive. You can think about it that way, right? So we went east. Then what we're going to say is that the total displacement that they're going to go at this point, so change in distance, and there's a little arrow over top now, right, to say we're talking about displacement, not distance. We just add the two together. But you can see that we had positive 10 because it was east going to the east, right? But then we're going to go plus negative, so minus 20, because now this is going to the left. So minus 20. So at this point, you would get, if you put this in your calculator, you get negative 10 meters, and you would know that that negative means 10 meters west. So either of those would be appropriate. You probably want to say west in the end in your answer just to be really explicit about what you mean. Okay, and then the last one, we just do the same thing. So um, you add all three together, keeping the negatives, keeping track of the negatives here. So we got positive 10, then negative 20, then positive 10. So the displacement of this person at the end was 0 because they are 0 away from their reference point. Okay, so I'm actually going to skip number 2. I'm going to let you guys look through that. It's similar to the ones that the one we just did. And number 3. Number 4, I'm just going to draw your attention to make sure that you're on the right track here. It says a man walks 75 meters west and then 192 meters east, so similar to above. And then this one, though, it brings up time. It says if the time required is 90 seconds, then what was the average speed of the man? So if this is looking for average speed, remember speed is also just a scalar. So if you're looking for speed, what we need to do is figure out our distance and then use our formula. So that's pretty much it, though. You need to make sure that you use the right, like if you're looking for a scalar quantity, you need to use a scalar quantity. So we need to find the distance, not the displacement. If the question said what was the average velocity, you would find the displacement and then use the same formula. The formula is the same, but you're just using the displacement instead of the distance. Okay, and that's, I'm going to let you guys look through B. And then I'd like you guys to do the homework assignment. So 1 to 5. Okay, I'll see you guys in the next video.